Okay, we started to talk about chapter 5, and I think this chapter is very important for those who doesn't learn anything about hypothesis testing, undergrads. And this is the basic technique to examine the relationship in regression analysis. For those who really doesn't have any backgrounds, please read this chapter carefully, okay? Read it. Not only just attend the class, but read it, okay? Then, of course, I will show the examples to all of you, and there's some rule to follow, step by step, okay? And first of all, let's see the, okay? On our textbook, page 147. Okay, this is the general rule to do the hypothesis testing. Did you all see that? I'll see whether I have all this. Maybe I don't have this. I didn't really show the steps here, but when I do the examples, sure. Okay, and we'll see that step on page 147. Okay, there's these 4 steps used to do the hypothesis testing. Okay, the first one is set up the null alternative hypothesis. You know, so far maybe they have a lot of terms which you didn't know, but I didn't put it here. Okay, turn to the page of 147. Do you all have the same page as mine? 147. Okay, and the lower parts of 147. Okay, you all see that 1, 2, 3, 4 on the bottom of on page 147. Okay, this looks like really preliminary school teaching. Okay, but this steps by step is important for all of you to follow. The first one is set up the null and alternative hypothesis. I'm going to explain it later on, okay? And choose the level of significance and therefore a critical value. Okay, 3, run the regression and obtain the estimated t-values or t-score, or maybe I'll say something about it, okay? Then number 4, apply the decision rule by comparing the calculated t-value with the critical t-value in order to reject or not reject the null hypothesis. So we are going to follow all these steps, okay, to explain first some special terms, okay, the meaning of the terms, and also apply all these examples to show how to do all this hypothesis testing, right? Okay, first of all, that's thinking. Before we go to the details of the hypothesis testing, let's thinking about some of the questions. Okay, so far when we learn from chapter 1 to chapter 3 and plus chapter 4 is the probability distribution, especially for the coefficient of the regression. Okay, and so some questions in our minds is like, is it likely that our result could have been obtained by chance? Since we just used the sample, right? Okay, so maybe our result is just, by chance. Okay, or we may think about that the result generated from our sample lead us to reject our original theory. All right, then some of you may thinking about how confident can we be that our estimate is close to the true value of the parameter. Okay, those questions, I think, must be in your mind. Okay, then we're going to introduce one of the inferential technique, okay, to support or to answer such as questions like this. Okay, all right, and since we have followed these 4 steps, okay, so from let's see. Okay, so the hypothesis testing and statistical inference allow us to answer important questions about the real world from the sample. Okay, and those questions is maybe just like what I just showed it in the previous PowerPoint. Okay, and we also say that the essence of econometrics, okay, the regression analysis is some part of econometrics, okay, is to quantify the economic relationship, quantify. Okay, when we say quantify means make some real numbers, okay? Quantify economic relationship by analyzing sample data and ask what conclusion can we draw from this quantification. Okay, so how can we get answers or questions or result from the sample data? Okay, and so we are going to talk about such many topics in these chapters, and I'll do it, just follow the step, okay, one by one. Okay, first of all, that's thinking about the hypothesis testing, okay? So would you turn to the page of 134 on our textbook, and since the first step is to state null and alternative hypothesis, so I'm going to explain what is null and alternative hypothesis. Okay? The null hypothesis, usually we denote it as H. H denotes as hypothesis, the capital letter of the hypothesis. Okay, and this is O, and this is 0. Okay, some of them use O, some of them use 0. Okay, and this null hypothesis specify a statement of range of values that researchers doesn't expect. Okay, then the other one is what we call alternative hypothesis. And remember, this alternative means the other choice, right? Okay, alternative hypothesis. Remember this one, we also call it research hypothesis. So when we have the name, research hypothesis means the statement of range of values of the researcher expect. You won't do the research, therefore this is what you expect. Okay, and look at the notation. This is H and A. A means alternative, and this A is matched with this O. O is null. What's the null means? Means empty, right? And if we have several alternative hypotheses, okay, in your research, okay, and we call it H1, H2, etc. Okay, and this match with the 0. Understand what I'm saying here? So this is usually what you see from the papers, articles. Okay, if they use HO, then alternative, they may use HA. And if they use H0 as the null hypothesis, then H1 or H2 may be their alternative hypothesis. So they are matching. Okay? And remember, alternative hypothesis is the research hypothesis. So for example, let me use one of the example. Okay? Some of you may, okay, here I see the bottle. Can I use this one? Okay, this one shows that this is 500 ml, 500 cc, right? So this is what the manufacturers say that the liquid in the drinks here weighs 500 ml. So if you are a customer, what do you think about this specification or this mark? Do you suspect whether the drinks here weighs 100 ml or less than 100 ml? If it is less than 500 ml, what do you think? What do you think? Or if it is over 500 ml, what do you think? As a consumer, okay, as a consumer, any idea about this one?
We got more if it is more than 100 ml, but it doesn't meet the specification of the manufacturer. Because in the manufacturer, usually they have the specification, the range may be between 490 milli up to 510 milli. If they have to produce, they need to meet that specification. And usually after it is produced, and it will be like tested by the authority, and it can be distributed if it is met the specification, I think.
Okay, like there's some specification here shows that 500 ml cc, right? So if they don't meet this specification, means the manufacturers cheated, right? Okay, and they may not have more than 500 cc. They may not have it. Why? If they contain more than 500 ml, then their cost increase, right? Right? So as a manufacturer, they do have some quality control lines or a department to check, to control the weight of this what they produce. But as a customer, okay, you worry about they may not meet the specification. Okay, maybe they just have 400 cc inside instead of 500, but it's stated 500 here. Okay, so as a researchers, if you stand on the consumer's side, okay, what do you like to check? What is your alternative hypothesis? What do you want to research for? You like to check whether the containers really have 500 ml, and you worry. What do you worry about it? Less than 500, right? So you put alternative hypothesis as, this bottle contains less than 500 cc. Okay? another example is like if you, nowadays we do have ordered food from some of the companies, then they will send you all this, what you ordered. And they may say that they can ship all this, deliver all this goods by 50 minutes. Okay? So if you are a consumers, what do you thinking about it? What do you worry about? What do you want to research? They claims that they can deliver the goods within or less than 50 minutes. So you really want to check whether they can deliver the goods smaller than 15 minutes, right? So this is one, what do you want? So whatever you want, put it as an alternative hypothesis. Then the other side, I mean the opposite of the alternative hypothesis will be in the null hypothesis. Therefore, this is the range of values the researcher does not expect. So if I use the regression analysis as an example, okay, usually when we do the hypothesis in regression analysis, we are testing all this coefficient, okay, except constant. In other words, I will test all the slopes, okay? So y equal to beta 0, beta 1, x1, beta 2, x2, etc., up to beta k, xk, plus epsilon. So this is the model of multiple regression. So most of the time, we're working with the hypothesis testing in regression analysis is going to test those coefficients. Therefore, I should put null hypothesis and alternative hypothesis. Okay? If I say that the x1 with y has positive relationship, in theory, if x1 and y has positive relationship, it means that the sign of beta 1 is positive, right? And usually we are working with the just relationship. We may not know the exact value of the parameters is, what values or what magnitude. We may not know, but we wanted to know the relationship is either positive or negative. Okay? So if the theory tells us that x1 and y has positive relationship, so what is the alternative hypothesis here? The theory shows the positive relationship. So what do you want to make it here as an alternative hypothesis? What do we mean by positive relationship? So we are going to testing the beta 1 greater than 0. Okay? Positive relationship. You want to test it as a beta 1 greater than 0. So what's the null hypothesis? Then beta 1 will be less than and equal to 0. So this is the whole story. This is a negative relationship. This is positive relationship. Okay? And since the theory shows the positive relationship with the x1 and y, so we are going to test beta 1, whether the beta 1 greater than 0. Okay? Again, if The theory says that x2 and y are negative relationship. So now we are going to test beta 2 is less than 0. Then this part will be greater and equal to 0. And there's many situations that we don't know whether they have positive or relationship or negative relationship, because according to the theories, they may have some positive, thinking, and the other one is negative thinking. Okay, and I say that I think that the example I'm going to use is, we just learned it, is the Woody 3. Woody 3's example. Then Woody 3, our y variables is the consumers what the bills, right? The bills. And the first one is I think it's N. N is what? Competition, competitors, right? So okay, so let me put this way, okay? The other one is called P. P is the population, right? So we say that, so let's put this one as a P. So if I have the X1 as the population, means that the more people, the more consumers, the more bills. Okay, so this is positive relationship. Okay, and N is the competitors. More competitors, smaller bills, customers. Okay, so this will be the negative relationship. And the other variables, okay, we make it X3, okay, and X3 is I. And we know that actually the income, will the income increase the customer's bill? And we know that from the examples, we say that this restaurant is family types restaurants. Okay, so there are some theories say that if we have more income, then we have more customer. And the other one says that, okay, sure, we may not have more customers if the income reach to some certain levels. If we have even richer families in this area, then since this is family size restaurant, is kind of a medium level restaurant. So if you have more income, you may like to go to the restaurant which with more, romantic or some other, environment. Okay, so if we do have higher customer, it may not really increase our customer. So I think these two theories is also reasonable, right? So in that case, we may wanted to check just relationship instead of positive or negative. You see what I mean? So in this case, what do I show from my alternative hypothesis? So now it's beta 3. I just want to know the relationship instead of positive or negative. So in that case, what do I show it here? What do we mean by relationship? What do we mean by, there's relationship exists? Means the beta 3 not equal to 0, right? It may not be positive. It may be positive or maybe negative. As long as it is not equal to 0, what do we mean by beta equal to 0? This is y, this is x3. What do we mean by beta 3 equal to 0? Means the horizontal, right? So the beta will be the horizontal. What do we mean by the beta is horizontal? Means that no matter x increase or decrease, y doesn't change. Right? So if you say beta 3 not equal to 0, means the relationship either positive or either negative, but not horizontal. Okay? Understand what I'm saying here? So the null hypothesis will be beta 0 equal to 0. Beta 3 equal to 0. This is not what I expected. I expected they do have relationship, so the beta is not equal to 0. You know, in the math, if beta 3 equal to 0 means the horizontal means there's no relationship between x3 and y. Okay? Understand what I'm saying here? All right? So this is what we call state null hypothesis and alternative hypothesis. That means your purpose of the research, right? So we call alternative is research hypothesis. Okay? So we have 3 types of hypothesis testing. Okay, in terms of alternative. So we always show the alternative first, then show the null hypothesis. But when you state it, there's no alternative hypothesis. State the null first, then alternative. But your logic thinking put the research hypothesis in alternative hypothesis. And the opposite side of the alternative hypothesis will be null hypothesis. Okay? So in this case, this 2 is saying that this direction, they do have direction. This is positive direction. This is negative direction. And this is, we can say 2 directions, either positive or negative. Therefore, we call these 2 are one-sided test. And this one is called two-sided test. So one-sided and two-sided is really depends on the direction of the alternative hypothesis. Okay? And do you see anything which, you like to say something about the alternative, now an alternative hypothesis? In other words, do you see something from one-sided test or two-sided hypothesis testing? Do you see something special? First of all, what I put on the alternative, now an alternative hypothesis, is the parameter. This is all Greek letters, right? This is the model. This is the model. And according to ordinary least square methods, I will, if I have the data, then I will have what? I will come up with the estimates which is beta 1, beta 2, or beta 3, and I put a hat on it. Okay? So when you do the hypothesis testing, you are testing parameters. Do not put the hat on it. Why? Why should we test the statistic? Now, always remember, parameter, the two words. Parameter and statistic. These two words. Okay, this is very important basic concept in statistics. What is the parameter? Is the numerical value to describe the characteristic of the population. So parameters always refer to population. Okay? And either signs or magnitude, I mean the values. Okay? All right? If we say 0, if we put 0 here, means we didn't really emphasize the magnitude, just direction, either positive or negative. Okay? So parameters always shows the characteristic of the population. But statistic, so we say this is beta, or the beta J. And this is all the beta J hat. When I put a hat, means use the sample to do the estimate, right? So this is really, say, the statistic is a characteristic to describe the sample. Okay? So if you have different sample, the beta hat will change, right? Right? You know, we just work with your assignments. You collect the data by yourself. We have A groups. So A group students collect different samples, right? And all these samples come out with different estimate of those betas. We do have same X variables. We have same Y variables, but we do have different samples. Therefore, for individual group, you end up with different beta, right? So beta hat is the statistic, okay? And this is from sample. Different samples, we do have different statistics. Therefore, the statistics is changed. And therefore, in chapter 4, we say that if we have as many as possible samples, then those beta hat, if we draw the diagram, it shows the relationship, or it shows the distribution. And this is what we call sampling distribution of the beta in chapter 4. That's why we have to learn the sampling distribution of the beta hat, right? Okay, understand what I'm saying here? I'm going to relate it to what we talk about here with the chapter 4. In the chapter 4 is really theory. You may not catch up all the abstract concept from chapter 4. But now I wanted to use those examples, use the chapter 5's hypothesis testing to do the relation, to connect these two chapters together. since all the statistics beta hat will be different, will be varied by different samples. Therefore, we do have the sampling distribution of the beta hat. With that sampling, the theory of the sampling distribution of the beta hat, then we can do the hypothesis testing here. Okay, I'm going to use the distribution of the beta hat. Since we do the hypothesis testing, this is talking about the parameters, talking about the population relationship. But how to test the population relationship is using samples, right? Without sample, how can I test the populations? And with the sample, and if with the good sample, then I can inference all this relationship from samples to the population. Understand what I'm saying here? So this is the essence of hypothesis testing. I'm using samples to inference the characteristic of the population. So this is our purpose. We're going to use the samples. Okay, we're going to use samples to show and give some evidence, although I haven't said anything about those evidence yet. Okay, so this is the purpose I wanted to do. Okay, I wanted to test the true relationship of the X variable to Y variable based on the theory. Okay, understand what I'm saying here? All right, so since we are all do the regression analysis, so our example is just show how to do the test hypothesis in regression analysis. Now we can do many other hypothesis testing, but here we focus on the regression analysis because this course focus on the regression analysis only. Okay, so most of the time we're working with the hypothesis testing. The null hypothesis, alternative hypothesis is something like this one. We have one-sided, we have two-sided. Okay, so the first important things you have to notice is when we do the null hypothesis testing, the statement here is according to the population parameters. So never say put the hat on it. If you put a hat on it, it's wrong. Okay? Always the parameters, just like what I put it here. No hat. No hat at all. Okay? Anything else you see from the null and alternative hypothesis statement? There's no equal signs on the alternative hypothesis. Never put the equal signs. You know, this is just greater than 0. This is less than 0. This is not equal to 0. All the equal signs are in null hypothesis. Right? Never put the equal signs in the alternative hypothesis. Because in theory, we know either they have positive relationship or negative relationship or just relationship, either positive or negative. All right? So you understand and this is called step 1. This is just step 1. The step 1 state the purpose of our research. Okay? Step 1. State null and alternative hypothesis. Is that clear? And you'll see that I started from just individual beta. I'll start with individual. But is it possible that I will make the several coefficients together? It is possible too, but I will start it from the simple one. Okay? In the regression analysis, if you do have several x variables, and you want to do check the relationship, hypothesize the relationship with individual x to y, then do the individual hypothesis testing for each one of them. And in some other cases, after we introduce all individual coefficient tests, then I will refer to, some possible combination test of the coefficients. But we started from the individual one. Okay? Is that clear here? Any questions about this? You may ask anything if you have some question in your mind. Do not thinking about, oh, maybe this is a foolish question. No foolish question in the classroom. You may have foolish question in the real world, but no foolish question in the classroom. Okay? So just, you can ask any questions you like. Do I make it clear here? Right? If it is clear, then I will go on. Okay? So for the first step is stating the null and alternative hypothesis. Okay? Now let's see. This is what I say, one-sided and two-sided. Okay? So this is exactly of what I put it there. And for this two are one-sided. If this is positive relationship, we say it is right-tailed. Why we call it right-tail? Okay, that's in some other steps. When I show the reason, then you know why do I say it right-tail test here. And if it is less than 0, means left tail. Okay? Then this two-tail, just two-tail. Okay, so one-sided, we have positive and negative. Positive is right-tail test, and negative is left-tail test. Okay? And this is some conclusion I just made it, okay? The null hypothesis contains equal sign in some form, either equal or greater than equal to or less than and equal to. All right? Second, always put what the researchers expect in the alternative hypothesis. And this allows to make rather statements when we reject the null hypothesis. So far, for all of you, reject the null hypothesis is, we don't know what is it, but never mind. This is what you have to know. Always put what the researchers expect in the alternative hypothesis. Okay? And there's one thing I wanted to remind you that never say that we accept null hypothesis. Okay? We must always say that we cannot reject the null hypothesis. So now I wanted to ask you, what's the difference between accept and cannot reject? Are they same? Let's see where's my pen? It's here. Okay. Is this two terms same? Are these two terms same? Same meaning? Do not reject or accept. This is nothing related to this hypothesis testing. I mean, thinking about in the real world. Yeah.
It's because we are put our expectation in alternative hypothesis. So if we say that we accept the null hypothesis, it means that we how to say, like our expectation is wrong. So we just saying that we cannot reject the null hypothesis even though the result is not meet our expectation.
Yeah, sure. That's very good. You'll hear what Rachel say. This alternative hypothesis is our expectation. Right? It's our research, our purpose. Okay? This is not our purpose. Okay? We can say accept alternative hypothesis, but do not say accept null hypothesis, because alternative hypothesis is our purpose. When we make the conclusions, always make the conclude according to alternative hypothesis instead of null hypothesis. So either we accept alternative or do not accept or reject alternative. Okay? Never say accept null hypothesis. Let me put it this way, okay? Maybe I'll ask one gentleman, okay? If you like to invite a girl to have a dinner with you, what do you expect from the girl? Huh? What do you expect from a girl? She may answer, yes, I do. And what is that? What does that mean? She accept your offer or something, or your invitation or something. Okay? If she said, I do not reject, what does that mean? You know, she may thinking about, well, nobody invite me tonight. And since you invite me, then why not? So I do not reject. Okay? So what are you thinking when you say, when you have the answer like do not accept or reject or accept? These two are really different, right? These two are different, right? And you like to have the answer is accept instead of do not reject, right? So this is what I'm trying to say, that do not reject and accept seems very, very close, but it is really far away. Okay? We'll talk about this later. Let's have some break, okay?